Hi, welcome to the FPGA vlog. With this video, I'm going to talk about FPGA. First, we look at what is FPGA. FPGA stands for Field Programmable Gate Array. It is an integrated circuit, but the special thing is it can be reconfigured even after its manufacturing. Due to this feature, it led users to prototype the functionality of the integrated circuit before its mass production. Let's look at the very basic architecture of the FPGA. It is made of logic cells, programmable interconnects, and I/O cells. Logic cell contains LUTs and flip-flops to make combinational and sequential logics. Programmable interconnects are used to build the connection between multiple logic cells to create the required circuit. FPGA device takes the inputs and outputs through the I/O cells. Now we look deeper into FPGA by identifying FPGA primitives. These are the main building blocks in an FPGA. LUT stands for lookup table. It is used for making combinational logics. How it is done? It is a small memory unit and it holds outputs for all the possible inputs of the given combinational logic. Consider we need to create the logic circuit shown here. It is a logic circuit with 3 inputs. So we can use a 3-input LUT with the values given in the table. Here, the input works as the address of the memory unit and output works as the stored element in each memory location. In such a way, LUT gives the correct output for the given inputs. Flip-flop is used to create registers in hardware. It can hold data for one clock period. DSP units are dedicated for implementation of multipliers and accumulators on FPGA. As multipliers and accumulators with large bit words consume a lot of LUTs, the FPGA manufacturers have developed DSP units inside FPGA. The picture shows a DSP unit used in Xilinx FPGAs. Its name is DSP48E2. It contains a 27-bit pre-adder, 27 into 18-bit multiplier, and a 48-bit post-adder. Block RAM is used for storing data in FPGA device. It is volatile memory. It gives both data writing and reading facilities. The memory size is changed from device to device. Now, we discuss why FPGA is special and important. We want to make 3 additions. If you want to make it done on FPGA, we can create 3 adders on FPGA, feed the inputs for all the adders, and the adders operate in parallel and output the results at the same time. You can see it is faster and reliable. Next, I will talk about processor architecture and how it performs 3 additions. This shows processor architecture: memory instruction, program counter, registers, ALU, and data memory. Instruction memory holds the machine code of the given program to be run. The program counter points each instruction to be executed. Registers holds the data until used it by ALU. Data to be processed can be loaded and processed data can be stored in the data memory. In this setup, each instruction is executed one after another and one data process done at a time. As only one ALU is used, this might be helpful to understand how 3 additions done on processor. If we want make this done with processor, we have to write a software. This shows program written using C language. Then it compiles and generate assembly. Finally, assembler convert it to machine code. Machine code is the machine understandable form of the instructions and it is executed one after another. So it gets slow compared to doing it on FPGA. This is why FPGA is better for faster processing. Now, we have come to the end of the video. Thank you.